The end of physics is not formulas, not theorems, but four monsters. This is not a joke. These four mythical beasts once drove the smartest human minds to madness. Maxwell was tormented by the first for his entire life. Schrödinger was pushed by the second into doubting existence itself. Einstein failed to tame the third until the day he died. And the fourth, to this day, has no question that any human can truly answer. They are not myths or legends. They are thought experiments forged by physicists themselves. With despair and madness. Maxwell's demon, Schrödinger's cat, Laplace's demon, Zeno's tortoise. These four beasts each point to a fundamental crack. At the very bottom of the universe. The second law of thermodynamics might be false. In the quantum world, a cat can be alive and dead at the same time. The future of the universe may have been written from the very beginning. And you can never catch up with a tortoise. What is more terrifying is that these are not jokes scientists tell for fun. They are fractures deep within the foundations of physics itself. More than 100 years have passed, and not a single one has been completely slain. They are still there, mocking human intelligence. Now let me take you into these four mythical beasts, starting with the oldest one of all. The first beast, Maxwell's demon. In 1867, the British physicist James Clerk Maxwell wrote a letter. That letter dropped a bomb into the world of physics. In it, he described a terrifying scenario. Imagine a sealed box filled with air molecules. A partition divides the box into left and right halves. In the partition is an extremely tiny door. Standing at the door is an invisible little demon. This demon has a special ability. It can see the speed of every single molecule. When a fast molecule flies toward the door, it opens it and lets it pass to the right. When a slow molecule approaches, it closes the door and keeps it on the left. Do you know what this means? The faster the molecules move, the higher the temperature. After being sorted by this demon, the right side fills with fast molecules and grows hotter and hotter, while the left side fills with slow molecules and becomes colder and colder. A box that originally had a uniform temperature is forcibly split into a hot half and a cold half by this tiny demon. This directly violates the second law of thermodynamics. Heat cannot spontaneously flow from a colder region to a hotter one. This is an iron law of the universe. Yet Maxwell's demon did it. Even more terrifying, if this demon really existed, a perpetual motion machine would no longer be a dream. You could use the temperature difference between the two sides to generate electricity, endlessly, without stopping. The fate of the entire universe would be rewritten. Because according to the second law of thermodynamics, the universe is heading toward heat death. All energy will eventually become evenly distributed heat. The temperature everywhere will be the same. No change, no motion, only eternal stillness. But if Maxwell's demon exists, the universe could be resurrected. This tiny demon drove physicists insane for more than 100 years. Until 1961, a physicist named Rolf Landauer stepped forward. He said that everyone had overlooked one crucial thing. For the demon to sort molecules, it must acquire information. It has to know whether each molecule is fast or slow. And acquiring information comes at a cost. In 1982, another physicist, Charles Bennett, delivered the decisive blow. The demon's memory is finite. After sorting so many molecules, its mind fills up with information sooner or later. What happens when it is full? It must erase old information to store new information. And the act of erasing information inevitably generates heat, increases entropy. In other words, the demon secretly lowers the entropy inside the box, but its own entropy increases. The total entropy of the entire system does not decrease. The second law of thermodynamics remains unshakable. In 2012, European scientists finally verified this experimentally. Erasing one bit of information requires at least kT-ln2 of energy. This number is extremely small, but it proves a shocking fact. Information is not some vague, abstract concept. Information has mass, has energy, and has a physical cost. Maxwell's demon did not violate the laws of physics. It merely hid the price inside information itself. Although this demon failed to overturn the second law of thermodynamics, it unexpectedly gave birth to an entirely new field, information thermodynamics. In 2024, Chinese scientists even used superconducting quantum chips to build a real, quantum version of Maxwell's demon, to study the relationship between quantum entanglement and thermodynamics. 150 years later, this little demon is still active on the frontiers of physics. The second beast, Schrödinger's cat. In 1935, the Austrian physicist Erwin Schrödinger proposed a thought experiment that still gives physicists around the world headaches today. Imagine a sealed box containing a cat. Inside the box is also a radioactive atom. The atom has a 50% chance of decaying. If it decays, it triggers a mechanism that shatters a vial of poison, and the cat dies. If it does not decay, the cat lives. Here is the question. Before you open the box, is the cat dead or alive? Most people would say, of course it is either dead or alive, we just don't know which. But quantum mechanics tells you that is wrong. Before the moment you open the box, the cat exists in a superposition of being both dead and alive. Not either dead or alive, but dead and alive at the same time. Only at the instant you open the box and observe it, does the superposition collapse into a definite state. Only then does the cat become either dead or alive. It sounds like madness, doesn't it? Schrödinger himself thought so too. He proposed this experiment to ridicule the Copenhagen interpretation of quantum mechanics. He wanted to say, look how absurd your theory is. How could a cat be both dead and alive? Einstein stood firmly on Schrödinger's side. He once famously said, when we are not observing the moon, does the moon cease to exist? But the eerie thing is that the predictions of quantum mechanics have been verified again and again in the microscopic world. Electrons really can pass through two slits at the same time. Photons really can take two paths simultaneously. Superposition is not an illusion. It truly exists. The real question is whether this strange property of the microscopic world can extend into the macroscopic world. Can a real cat exist in a superposition? To this day, no one knows the answer. But scientists keep trying to make the cat bigger and bigger. In 2024, a team at the University of Science and Technology of China set a new record. They used laser beams to trap about 10,000 atoms and placed them simultaneously into two opposite quantum states. And this superposition lasted for a full 23 minutes. Previous experiments could only maintain superposition for a few seconds. This shows that quantum superposition can exist far longer than we once imagined. In 2025, scientists in Austria and Spain discovered that creating quantum superposition does not necessarily require cooling a system close to absolute zero. Superposition can be observed even in relatively warm environments. What does this mean? It means the boundary between the quantum world and the classical world we are familiar with may be far blurrier than we thought. IBM researchers even used 120 qubits to create the fattest Schrödinger's cat ever as a benchmark for quantum computer performance. Schrödinger originally used this cat to mock quantum mechanics. Yet 90 years later, this cat has become a core tool of quantum computing. History's irony rarely cuts deeper. The third beast, Laplace's demon. This beast is the embodiment of the most despair-inducing reasoning in human history. In 1814, the French mathematician Pierre-Simon Laplace proposed an idea. If there existed an all-knowing intelligence in the universe, one that knew the position and velocity of every particle, then by plugging those values into Newton's equations of motion, it could calculate the past and the future of the universe, the trajectory of every planet, the motion of every atom, what you eat today, what you say tomorrow, when you are born, when you die, all of it was already determined. At the very moment the universe was born 13.8 billion years ago. This is Laplace's demon. It does not need to predict the future, because the future is the inevitable result of the present. It does not need to change anything, because everything is already written. You think you have free will, you think you can choose your destiny. Before Laplace's demon, all of that is an illusion. Every choice you make, every thought you have, is merely the inevitable result of atomic motion. You are not making decisions. You are simply acting out a script written long ago. This idea pushed many people to the brink of collapse. If everything is predetermined, what meaning does life have? If free will does not exist, where do morality and responsibility come from? Laplace's demon is not a mythical beast. It is a devil. But humanity did not give up. In 1926, Werner Heisenberg proposed the uncertainty principle. He proved that you cannot precisely measure both the position and momentum of a particle at the same time. The more accurately you measure position, the more uncertain momentum becomes. The more accurately you measure momentum, the more uncertain position becomes. This is not a limitation of instruments. It is a rule of the universe itself. Laplace's demon wants to know the position and velocity of every particle simultaneously. Sorry, the laws of physics forbid it. Then chaos theory delivered another blow. Even if you know the initial conditions, a tiny, infinitesimal error can lead to completely different outcomes. The butterfly effect is the best example. A butterfly flapping its wings may trigger a storm on the other side of the Earth. At the quantum level, such errors are unavoidable. Laplace's demon is dead. It survived for only about 100 years, the shortest lived of the four beasts. But the debate over determinism and free will has never stopped. Quantum mechanics tells us the universe contains randomness. But is this randomness truly random, or does it hide laws we do not yet understand? This question remains unanswered. The fourth beast, Zeno's tortoise. This is the oldest of the four beasts. Born in ancient Greece 2,500 years ago, the philosopher Zeno posed a question. That looks like mere sophistry. The fastest warrior in ancient Greece, Achilles, races against a tortoise. The tortoise is given a 100-meter head start. Only then does Achilles begin to chase it. Achilles runs 10 times faster than the tortoise. By common sense, catching it should be effortless. But Zeno said no, Achilles will never catch the tortoise. Why? When Achilles runs the first 100 meters, and reaches the tortoise's starting point, the tortoise has already crawled another 10 meters ahead. When Achilles runs those 10 meters, the tortoise crawls another 1 meter. When Achilles runs that 1 meter, the tortoise crawls another 0.1 meters. This process can repeat infinitely. The tortoise can always create a new distance between itself and Achilles, no matter how small. As long as that distance exists, Achilles can never catch up. It sounds like nitpicking, but Zeno was really asking a profound question. Can time and space be divided infinitely? If they can, then there are infinitely many moments in time, and infinitely many moments added together should produce infinite time. Achilles truly should never catch the tortoise. But in reality, Achilles obviously can pass the tortoise with ease. So where did the reasoning go wrong? This paradox haunted humanity for more than 2,000 years. It was not until modern mathematics developed that people realized that infinitely many positive numbers added together do not necessarily equal infinity. They can converge to a finite value. This is the concept of convergent infinite series. Mathematically, the paradox was resolved, but physics offered a deeper answer. Quantum mechanics tells us that time has a smallest unit, called Planck time, about 10 superscript 3 seconds. Space also has a smallest unit, called Planck length, about 10 superscript 3 meters. Time and space smaller than these scales have no physical meaning. In other words, time and space cannot be divided infinitely. The tortoise cannot create infinitely many starting points. When the chase reaches the Planck scale, Achilles instantly overtakes the tortoise. With what seems like a trivial paradox, Zeno's tortoise forced humanity to confront the nature of time and space. It took us 2,500 years to barely arrive at an answer. But that answer raised new questions. What do Planck time and Planck length truly mean? Is space-time continuous or discrete? Is the universe we live in like a computer screen, made of countless pixels? 4 beasts. 4 questions. Maxwell's demon asks about the relationship between information and energy. Schrödinger's cat asks how observation determines reality. Laplace's demon asks whether the universe has free will. Zeno's tortoise asks about the nature of time and space. More than 100 years have passed. Laplace's demon was killed by quantum mechanics. Maxwell's demon was tamed by information theory. Zeno's tortoise was trapped by the Planck scale. Only Schrödinger's cat remains, still alive and dead at the same time, mocking every human who tries to understand it. But the meaning of these beasts was never about killing them. Their meaning lies in this: every attempt to tame them has pushed human understanding to a new frontier. Maxwell's demon gave birth to information thermodynamics. Schrödinger's cat propelled quantum computing. Laplace's demon sparked chaos theory. Zeno's tortoise inspired the quantization of spacetime.